Picture this. The vast Pacific Ocean stretches endlessly before you, its surface deceptively calm under the pre-dawn darkness of October 1944. Somewhere in these waters, two naval forces are about to collide in what would become one of the most shocking encounters of the Pacific War. On one side, a formidable Japanese task force commanded by seasoned admirals who had dominated these waters for years, their ships cutting through the waves with the confidence of warriors who believed they held every advantage. On the other side, a small group of American destroyers that appeared hopelessly outgunned and outmatched, their crews young and relatively inexperienced compared to their battle-hardened enemies. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. What the Japanese commanders didn't know as they prepared for what they assumed would be a routine victory was that these seemingly vulnerable American ships carried a secret weapon that would completely revolutionize naval warfare forever. A technology so advanced, so precisely engineered, that it would turn the fundamental principles of sea combat on their head in a matter of minutes. This wasn't just about superior firepower or better tactics. This was about a breakthrough that made the impossible suddenly inevitable, transforming certain defeat into stunning triumph through the power of innovation that the enemy never saw coming. The story you're about to hear reveals how a single technological advantage, hidden from enemy intelligence and unknown to even most American sailors, changed the course of naval history in ways that military strategists are still studying today. It's a tale of scientific genius meeting raw courage, of engineering precision colliding with the chaos of battle, and of how sometimes the most significant victories come not from brute force, but from the quiet revolution of minds that dared to reimagine what was possible on the high seas. The morning sun had barely crested the horizon when Lieutenant Commander Samuel Harrison received the order that would test everything he thought he knew about naval combat. Standing on the bridge of the USS Caldwell, a Fletcher-class destroyer that had seen more action in the past 6 months than most ships experienced in their entire service life, Harrison studied the intelligence reports that had just arrived via encrypted radio transmission. The Japanese were moving a significant force through the Leyte Gulf region, and American naval intelligence suggested this wasn't just another routine patrol or supply run. What made this particular morning different from the countless others Harrison had experienced during his 18 months in the Pacific Theater was the presence of a device that most of his crew didn't fully understand, and that the Japanese Naval Command had no idea existed. Mounted discreetly within the ship's fire control system was a Mark 37 gun fire control system, equipped with the revolutionary Mark 25 radar unit, a piece of technology that represented years of secretive development by American scientists and engineers working around the clock in laboratories thousands of miles from the front lines. The radar system itself was a marvel of wartime engineering that pushed the boundaries of what was scientifically possible in 1944. Unlike the primitive radar systems that had been used earlier in the war primarily for detection and basic ranging, this new technology could track multiple targets simultaneously while calculating precise firing solutions in real time, automatically adjusting for factors like target speed, distance, wind conditions, and even the subtle movements of the destroyer itself as it maneuvered through the swells. The system could lock onto enemy vessels at distances that exceeded visual range, maintaining accurate targeting even through smoke, rain, or the confusion of battle conditions that had previously made accurate gunnery nearly impossible. What truly set this technology apart was its integration with the ship's 5-inch guns, creating a weapon system that could engage targets with a level of precision that veteran naval gunners found almost supernatural. The radar could track an enemy vessel moving at high speed across the water, calculate the exact point where the target would be when the shells arrived, and automatically adjust the gun elevation and bearing to ensure hits that previous generations of naval officers would have considered miraculous. This wasn't just an improvement in existing technology, it was a fundamental transformation in how naval warfare could be conducted, turning gunnery from an art based on experience and intuition to a science governed by mathematical precision. The development of this radar-guided fire control system had begun in the early years of the war, when American naval strategists realized that traditional methods of naval gunnery were becoming increasingly inadequate against the sophisticated tactics employed by Japanese naval forces. The Imperial Japanese Navy had demonstrated remarkable skill in night fighting and long-range engagements, often using superior training and experience to overcome American numerical advantages. American engineers and scientists, working in collaboration with military planners, recognized that technological innovation might provide the edge needed to level the playing field and potentially gain decisive advantages in crucial engagements. The scientific principles behind the radar system involve transmitting high-frequency radio waves toward enemy targets and analyzing the reflected signals to determine precise distance, speed, and bearing information. However, the real breakthrough came in developing the computational capabilities needed to process this information quickly enough to be useful in the rapid-fire environment of naval combat. Engineers created analog computers that could perform complex ballistic calculations in seconds rather than the minutes required by human operators, allowing the system to track multiple targets while continuously updating firing solutions as conditions changed during battle. Lieutenant Commander Harrison had been one of the first destroyer captains to receive training on this new system during a brief but intensive course at the Naval War College several months earlier. The training had been conducted under strict security protocols, with officers required to sign confidentiality agreements and warned that any discussion of the technology outside authorized channels would result in court-martial proceedings. Even within the Navy, knowledge of the system was compartmentalized, with only essential personnel receiving information about its capabilities and limitations. During the training sessions, Harrison had been amazed by demonstration exercises that showed the radar system successfully tracking and engaging target drones at ranges that would have been impossible using conventional optical fire control methods. The system could maintain accurate targeting even when the target vessel was partially obscured by smoke or maneuvering evasively, and it could engage multiple targets in rapid succession without the time delays typically required for manual range finding and calculation procedures. The instructors had emphasized that this technology represented not just a tactical advantage, but potentially a strategic game changer that could alter the balance of power in Pacific naval operations. The secrecy surrounding the radar system extended beyond just the technical specifications to include strict protocols for its deployment and use in combat situations. Destroyer captains were instructed to use the system only when absolutely necessary, and to take measures to prevent enemy forces from recognizing its existence or capabilities. This meant that in many engagements, ships equipped with the radar system continued to use conventional fire control methods to maintain the illusion that American gunnery capabilities remained unchanged from earlier in the war. As Harrison prepared his ship for the upcoming engagement, he reviewed the tactical doctrine that had been developed specifically for radar-equipped destroyers. The new technology allowed for engagement strategies that would have been impossible or extremely risky using traditional methods, including the ability to engage enemy vessels at maximum range while maintaining high accuracy, and the capacity to fight effectively in conditions of limited visibility that had previously favored Japanese forces with their superior night fighting training and experience. The crew of the USS Caldwell represented a cross-section of American naval personnel, ranging from seasoned petty officers who had served since before the war began to young sailors who had enlisted immediately after Pearl Harbor and received their training in the rapidly expanding wartime Navy.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means most of the crew members were aware that their ship carried advanced equipment, but the specific capabilities and revolutionary nature of the radar system were known only to a handful of officers and senior enlisted personnel who had received specialized training and security clearances. Chief Petty Officer Michael Rodriguez, who served as the ship's senior fire control technician, had been among the first enlisted men to receive training on the new radar system. With 15 years of naval service and experience on multiple ship types, Rodriguez understood better than most how dramatically this technology could change naval combat. He had spent countless hours during the voyage to their current position training junior technicians on the proper operation and maintenance of the system, emphasizing the critical importance of keeping the equipment operational under the stress and chaos of combat conditions. The radar system required constant maintenance and calibration to maintain peak performance, with technicians monitoring dozens of vacuum tubes, complex wiring systems, and mechanical components that were all susceptible to the vibrations, temperature variations, and electrical interference common in naval combat environments. Rodriguez had developed detailed maintenance protocols and trained backup operators to ensure that the system would remain functional even if primary operators were injured or killed during battle, recognizing that the technology was only as effective as the personnel trained to operate it under extreme conditions. As the morning progressed and intelligence reports continued to arrive, it became clear that the Japanese force approaching their position was significantly larger and more heavily armed than initially estimated. The enemy task force included multiple heavy cruisers and destroyers under the command of experienced officers who had participated in numerous successful engagements throughout the Pacific War. For the small American destroyer force, this represented exactly the type of engagement where their technological advantage might prove decisive, but only if they could employ the radar system effectively while preventing the enemy from recognizing and adapting to their capabilities. The stage was set for an encounter that would test not only the effectiveness of American technological innovation, but also the courage and skill of the sailors who would have to employ this revolutionary system under the extreme pressure of combat against a formidable and experienced enemy force. The next few hours would determine whether years of scientific research and engineering development could translate into tactical success when faced with the ultimate test of naval warfare in the vast Pacific Ocean. The first contact came at 0847 hours, when Seaman First Class David Chen, stationed at the ship's primary radar console, detected multiple surface contacts approaching from the northwest at a distance of 28 nautical miles. Chen had been operating radar equipment for only 7 months, but his training had been intensive and his natural aptitude for the electronic systems had quickly earned him recognition from his superiors. As he watched the green phosphorescent blips moving across his scope, he immediately recognized the formation pattern and speed characteristics that indicated a major enemy naval force. Contact bearing 315 degrees, range 28,000 yards. Multiple large surface vessels, Chen reported to the bridge through the ship's internal communication system. His voice carried the calm professionalism that had been drilled into radar operators during their training, but Lieutenant Commander Harrison could detect the underlying tension that came with the realization that they were about to face their first major engagement against a superior enemy force. On the bridge, Harrison studied the tactical display that showed not only his own ship's position, but also the locations of the 3 other American destroyers that comprised their small task force. The USS Manning, USS Foster, and USS Delaware were positioned in a loose formation that would allow them maximum flexibility in maneuvering while maintaining the ability to concentrate their firepower against enemy targets. Each ship was equipped with the same revolutionary radar system, creating a coordinated weapons platform that possessed capabilities far beyond what their individual firepower might suggest. Admiral Takeshi Yamamoto, commanding the Japanese task force from the heavy cruiser Kumano, was reviewing his own intelligence reports and battle plans as his ships approached what he believed would be a routine engagement against a small American destroyer force. Yamamoto was a veteran of numerous Pacific engagements, including the early victories at Pearl Harbor and the Philippines, and he possessed the confidence that came from years of successful combat operations against American naval forces. His task force included 2 heavy cruisers, the Kumano and the Suzuya, along with 4 destroyers, giving him overwhelming firepower advantages against any destroyer force the Americans might deploy. The Japanese admiral's battle plan was straightforward and based on proven tactics that had served the Imperial Navy well throughout the war. His heavier ships would engage the American destroyers at long range, using their superior gun caliber and armor protection to inflict maximum damage while remaining outside the effective range of the smaller American vessels. The Japanese destroyers would then move in for close-range torpedo attacks to finish off any American ships that survived the initial bombardment. It was a textbook approach that had succeeded in previous engagements, and Yamamoto saw no reason to expect different results this time. What Admiral Yamamoto did not know was that his opponents possessed the ability to engage his ships with deadly accuracy at ranges that exceeded his own visual targeting capabilities. The Mark 37 fire control system aboard each American destroyer could track his vessels while they were still beyond the horizon, calculating precise firing solutions and preparing to deliver devastating salvos before the Japanese force could even determine the exact positions of their targets. Lieutenant Commander Harrison ordered his task force to assume battle formation while maintaining their approach toward the enemy contacts. The 4 American destroyers arranged themselves in a line formation that would maximize their radar coverage and allow for coordinated fire control operations. Each ship's radar system was now tracking the approaching Japanese vessels, with operators continuously updating range, bearing, and speed information that was being fed directly into the fire computers. The technological advantage possessed by the American force extended beyond just the radar systems themselves to include the sophisticated fire computers that could process targeting information far more rapidly and accurately than human operators using traditional optical range-finding methods. These analog computers, which represented cutting-edge technology for their time, could simultaneously track multiple targets while calculating complex ballistic trajectories that accounted for wind speed, ship movement, target maneuvering, and dozens of other variables that affected gunnery accuracy. Chief Petty Officer Rodriguez was stationed at the main fire control console, monitoring the stream of data flowing from the radar system to the gun control computers. His experienced eye could interpret the electronic displays and recognize patterns that indicated enemy course changes, speed adjustments, or tactical maneuvers. Rodriguez had participated in several previous engagements using conventional fire control methods, and he was acutely aware of how dramatically the new technology improved their chances against a numerically superior enemy force. As the range closed to 15 nautical miles, the Japanese ships became visible on the horizon as small dark shapes against the morning sky. Admiral Yamamoto, observing from his flagship's bridge, could see the American destroyers approaching and began issuing orders for his ships to assume battle formation. The Japanese force arranged itself with the 2 heavy cruisers in the center, flanked by pairs of destroyers that would protect against torpedo attacks while contributing their own firepower to the engagement.
The first salvos were fired simultaneously by both forces at a range of approximately 12 nautical miles, marking the beginning of what would become one of the most technologically significant naval engagements of the Pacific War. The Japanese shells, fired using traditional optical fire control methods, fell short of their intended targets as the gunners struggled to accurately estimate range and bearing against the maneuvering American destroyers. The sound of the heavy shells impacting the water several hundred yards from the American ships created towering columns of spray that confirmed for Harrison and his officers that they had achieved their first tactical advantage. In stark contrast, the American salvos, guided by the precision of radar fire control, struck their intended targets with devastating accuracy. The 5-inch guns of the USS Caldwell, trained automatically by the radar system, delivered a pattern of hits along the waterline of the Japanese destroyer Akikaze before the enemy ship's crew could even confirm the American vessel's exact positions. The explosive shells penetrated the destroyer's thin armor plating and detonated within the ship's engine compartments, creating massive internal damage that immediately reduced the vessel's speed and combat effectiveness. The crews of the Japanese ships were stunned by the accuracy of the American gunnery, which exceeded anything they had experienced in previous engagements with American naval forces. Veteran Japanese gunners who had participated in numerous successful battles found themselves facing an enemy that could place shells precisely where intended from ranges that should have made accurate fire impossible.
The psychological impact of this unexpected capability began to affect Japanese morale even before the full extent of their technological disadvantage became apparent. Lieutenant Commander Harrison watched through his binoculars as secondary explosions erupted aboard the damaged Japanese destroyer, sending flames and smoke billowing across the water. The radar system was already shifting its focus to the next target, the heavy cruiser Suzuya, while maintaining tracking information on all enemy vessels simultaneously. This multi-target capability allowed the American destroyers to engage multiple enemy ships in rapid succession without the time delays that traditionally allowed damaged vessels to withdraw or reorganize their defensive formations. The Japanese heavy cruiser Kumano returned fire with her 8-inch main battery, sending massive shells screaming toward the American formation. However, without the benefit of radar fire control, the Japanese gunners were forced to rely on visual range-finding techniques that were inherently less accurate, especially against fast-moving targets at extreme range. The shells impacted the water around the American destroyers but failed to achieve the devastating hits that Admiral Yamamoto had expected from his superior firepower. As the engagement intensified, the technological disparity between the two forces became increasingly apparent. The American destroyers could maintain accurate fire while maneuvering at high speed, with their radar systems automatically compensating for the ship's movements and maintaining precise targeting solutions. The Japanese ships, handicapped by their reliance on optical fire control methods, found their accuracy degrading significantly whenever they attempted evasive maneuvers or operated in conditions of limited visibility created by smoke and spray from shell impacts. Seaman Chen, monitoring the radar displays, reported multiple hits on enemy vessels while tracking the movements of the Japanese formation. The radar system was providing a comprehensive tactical picture that allowed Harrison to anticipate enemy maneuvers and position his ships to maximum advantage. This situational awareness capability represented another crucial advantage of the radar technology, enabling the American commanders to make informed tactical decisions based on real-time information about enemy positions, speeds, and courses. The Japanese destroyer Akikaze, severely damaged by the initial American salvos, began to fall behind the main formation as her crew struggled to control flooding and maintain power to essential systems. The ship's captain, Commander Hiroshi Tanaka, had served with distinction throughout the war and immediately recognized that his ship was facing weapons capabilities that exceeded anything in his previous combat experience. Despite his crew's heroic efforts to maintain their vessel in fighting condition, the accumulated damage from multiple precise hits made continued effective resistance impossible. Admiral Yamamoto, observing the unexpected effectiveness of American gunnery, began to suspect that his opponents possessed some form of advanced fire control capability that his intelligence services had failed to detect. The pattern of hits achieved by the American destroyers suggested a level of accuracy that should have been impossible at such extreme ranges using conventional targeting methods. However, the nature of the American technological advantage remained unclear, and Yamamoto continued to believe that aggressive tactics and superior firepower could overcome whatever innovations the Americans had deployed. The USS Manning, operating in coordination with the Caldwell, shifted her fire to the second Japanese destroyer in the enemy formation. The radar-guided 5-inch guns achieved hits with their first salvo, demonstrating the devastating effectiveness of coordinated fire from multiple radar-equipped vessels. The Japanese ship, caught completely off guard by the precision of the American gunnery, suffered critical damage to her forward magazine areas, resulting in a catastrophic explosion that broke the vessel in half and sent her to the bottom within minutes. The loss of 2 destroyers in rapid succession forced Admiral Yamamoto to reconsider his tactical approach, but his options were severely limited by the continued accuracy of American fire and his inability to close the range effectively against opponents who could maintain precise targeting at distances that exceeded his own effective engagement range. The Japanese heavy cruisers possessed superior armor protection and firepower, but these advantages were negated by their inability to achieve hits against targets that could predict their movements and maintain devastating accuracy despite the chaos and confusion of naval combat. As the morning battle continued, the technological revolution represented by radar-guided fire control was proving its decisive impact on naval warfare. The American destroyers, previously considered vulnerable to heavy enemy units, were systematically destroying a superior Japanese force through the application of scientific precision to the ancient art of naval gunnery. The engagement was demonstrating that technological innovation could overcome traditional advantages in firepower and experience, fundamentally altering the balance of power in Pacific naval operations. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.